For those of you that are watching right now, I just put 3 links into the description of this video. One of them being the sample t-test problems that I am going to be reviewing, and the thing that I've been working on in preparation for this particular live stream. I wanted to review some questions from the 2001 AP test. So we'll get started in just a couple minutes. Allow some people to kind of get in there into the chat. But yeah, I do have some links in the description to kind of put in there. Kyle, you're never late. You're always here on time. Nice. But yeah, for those of you that are joining, I have some links in the description for you. Those are the things that I'm going to be working on in a few minutes with you while people kind of are strolling in without their late passes into the chat. I'm trying to get my stuff. There it is. I had worked through these problems earlier. I want to make sure I have them here. There we go. I will mention this again later, but for those of you that are wondering, the 2001 test, the reason why I'm going over the 2001 test with you is because that happens to be the very AP statistics test that I took when I was in high school. So, just in case you were wondering or interested, that is the one that I rocked when I was in 11th grade or something like that. I gotta get one more link ready for myself, just in preparation for this. There it is. Make sure you're clicking that like button, as Kyle likes to say, and and subscribing and ringing that bell so you get notifications. Just trying to have another link open for myself. Which one did I get you? Okay, there's my Google Classroom. You all had an assignment due, as most of you have turned in. Good for you. I could name the people that didn't, but I don't want to embarrass them. Okay, those 2 questions. It was 12 and 13 that I had you do. And 13. There we go. Okay. I just wanted to make sure I had the right ones. Excellent. 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 Okay. Cool. So just so I know who I'm talking to as people are coming in, just give a hello, give a comment, just so I can see. I got like 8 or 9 people watching right now. Randomly, I had a person earlier this morning that used to watch my videos from back in the day. Oh, there's a big stat day. Oh, people are coming in and out, apparently. Oh, goodness. Who in the world liked that tweet? Sorry. I tweeted this morning, and it wasn't my typical type of tweet that people like to see. So, okay, I'll fill you guys in. Kyle already knows this story, but I'll fill the rest of you guys in that are watching right now. Yesterday, I was in the middle of a live stream for my Algebra 2 students, and we had just finished the section on simplifying rational functions. No, we were reviewing. That's right. We were reviewing various problems with rationalizing, simplifying rational functions. My brain is all a mess right now. Long story short, in the middle of that stream, my daughter fell off the top bunk of my son's bed. My son has a bunk bed. It's a loft bed. So like, what do we put? Yeah, there's a chair underneath and stuff like that. But anyway, she fell off the top bunk. And what ended up happening was, well, after a virtual live stream visit with the doctor, after calling however many offices that I needed to call because there was no way we were going to send her to the ER with everything that's been going on. Long story short, she had broken two bones in her arm, um, and that sucks. So pretty much from like noon yesterday until about I don't even know, noon until like 5 or 6 o'clock or something like that. It was just like nonstop shuttling myself to different places, shuttling her, bracing the outdoors of this climate that we now have, and getting her to get an X-ray, and uh, and finding the right medicine because most of the stores are cleaned out, getting like children's medicine and stuff like that. Who the heck is fettuccine? Anyway, um, but yeah, today I have to drive her up to Freehold, and they're either going to set her arm in a cast or give me some kind of a brace or something. We'll see what happens. Ah, there he is. Jacob, you missed my story about how my daughter broke her arm yesterday during a live stream. He... Oh, wow. I didn't even know what kind of face you were going for there for a second. But yeah, I got that. Yes, it is. She fell off the top bunk of my son's bed in the middle of me live streaming to my Algebra 2 students. It was upsetting, to say the least. I don't know. Oh, well. Uh, yeah, but that's how my day's been going. I had to go get the x-rays. Yeah, they are cool, but I had to go get the x-rays from the Health Village imaging. I had to go... it was just a mess. All right. We're going to get started in just a moment. Make sure you're clicking that subscribe button. Everybody click a like and ring that bell. And we'll kind of get going with what we're doing. Now, today you had t-test practice in a PDF that I had attached to Google Classroom. And if you go down to the links in the the links in the description, I have 3 links there. One for sample t-test. If you click that, it'll bring you right to the PDF of the 2 problems that we're going to review first. And then after that, there is the 2001 AP test question set. Now, I'm not going to go over every single question in the 2001 test. Not every single question. I'm actually hoping to only go through numbers 1 through 5. Number 6 happens to be something that I am pretty confident that they're not going to test you on, simply because they said the first 75% of the curriculum, and that problem that I might omit is not, and it's not something that I've ever taught you before, but we'll deal with that when the time comes. Oh, and there's a knock at my door. Hold on 1 second. Yes, James. Okay, come on in. We'll do that real quick. Oh, goodness. Goodness. I don't remember. Nice. Question for all of you in the stream right now. Do you have a suggestion as to the type of picture that my son should get printed out so that he can color it. He has been a fan of what, Pokemon recently?
Yeah.
Pokemon and what else? I forget. What is that other thing you like printing out? That's right. Yeah, Captain Underpants or something like that. Who is Snivy? Should I even be searching for this? Oh, he's a Pokemon. Okay, hold on.
Snivy.
Let's take a look. You know who Snivy is, James?
Yeah.
Hold on. Pokemon coloring page. Do you like that one?
Could you tell them that I like Pokemon Sun and Moon?
You don't want those three? Those are the starter Pokemon from some generation that he liked.
Hey, I like that. I have that piggy one.
Yeah, Tepig?
Yeah.
Yeah.
Can you tell them that I like Sun and Moon?
Okay, cool. Do you have any, Jacob, do you have any Pokemon from Sun and Moon? My son has recently really, really liked Sun and Moon. Let's try something. Let's try that one.
Did it say anything about it?
Nothing yet. Hold on. Pokemon coloring page.
Well, if you don't know if they said it.
He's suggesting Mimikyu. Do you want Mimikyu?
Yeah, Mimikyu on him.
Okay. Let's go with Mimikyu then. Images. Which Mimikyu would you like? For those of you who have no idea what we're talking about, Google search Mimikyu. Which one are you looking for, kid?
Like up.
Up.
That one.
This one?
Yeah.
Okay.
Hey.
Let me make him a little bigger, okay?
Hi.
There he is. Print. Okay. Also, wishy-washy or big fish.
I asked one.
Katie, you can't give out gold stars.
What?
That's true. They are indeed earned. Buddy, we'll worry about printing out another one later. Okay, just focus on doing this one. Oh, they do?
Yeah, but it's not while they go back to normal.
Oh, okay. All right. Cool, cool. All right, now, James, I am going to lock the door, okay? Okay. James, one more thing. Make sure you don't disturb Mommy. Okay. Oh, okay. The perils of trying to teach when you are at home. Your son wants to print a picture. Your daughter breaks her arm. Anyway. Yeah, Jacob, he's James Markey the Third. What are you talking about? I thought you knew this. Oh, well, I apologize, kind sir. Anyway, for those that are going to come back and watch this, I'll put in timestamps per the usual. I know we're like 20 minutes in now, but we're just kind of like shooting the breeze right now. I don't even know. Let's talk about what we're supposed to do. Now, I had a few people contact me just as an aside. I had a few people contact me in the regards to the use of graphing calculators. As of right now, I don't know if you don't have a graphing calculator. I don't know how they're going to handle it on the AP test. It's a good question for the AP coordinator and guidance, Miss Gerke. I'm going to probably have to send her an email and figure that out. Because if you don't have a graphing calculator, if you don't have the capabilities of running certain tests, I don't know. We'll see what happens. Anywho, let's start with the first problem. So the first problem, you know what? I'm going to print this sucker out. I think this would be good. If I print out this page, then it would be most appropriate. Come on, you. Okay, that is not printing properly. Come on. Go back to normal. There we go. I'm going to print out this sucker so that I can put it underneath here. I'm not going to print out the whole test, but we'll figure that out when the time comes. But I'll start reading through the first problem. So the first problem that we had, there's a father who is concerned that his teenage son is watching too much television each day. Ooh, COVID. Since his son watches an average of 2 hours per day. Okay. His son says that his TV habits are no different than those of his friends. Here we go. I got it right here. I'm going to zoom in. Good. Almost. Almost. Come on, you silly camera. There we go. No different than those of his friends. Since this father has taken a stats class, fun, he knows that he can actually test to see whether or not his son is watching more TV than his peers. Here we go. The father collects a random sample of television watching times from boys at his son's high school and gets the following data. Boom. Is the father right? That is there evidence that other boys average less than 2 hours of television per day? Conduct a hypothesis test, making sure to state your conclusions in the context of the problem. First and foremost, I am going to have to enter my data into my graphing calculators list in order to get some important information. 2.2. Let's double check that. Boom, boom, boom. Always double check to make sure that your numbers are typed in correctly. There we go. I'm going to run a 1var stat. Boom. Now, what's really nice about running a 1var stat on the TI graphing calculator is that this data would automatically be entered into whatever test you're trying to run, which is fantastic. So, I could probably already answer this question, but I'm going to run through the hypothesis test regardless. But I could probably already answer this question based on the fact that x bar is equal to 2.01 and sample standard deviation is 0.345. Interesting. So I'm looking at that junk. There we go. And this is the information that I would potentially need in order to answer this question. Now, as a side note, 1, 2, 3, 4, 6, 7, 8, 9, 10. Are there 10? Yeah, there's 10. The sample size is 10. If they're going to ask you about degrees of freedom, again, remember, degrees of freedom are n-1 for these t-tests. So just for the sake of argument and whatnot. But they want me to conduct a hypothesis test. I'm most likely going to want to run a 1-sample t-test. In order to do that, I will have to do certain assumptions and conditions, but let's run through it a piece at a time. First and foremost, my null hypothesis. The son is claiming that 2 hours is no different than any of his friends. The sample taken is of his friends, clearly, but so he's claiming that 2 hours is just fine. Null hypothesis. Innocent until proven guilty. The father is looking at a sample and trying to see whether or not his son is really telling the truth. The father believes, now this is the key part here. The father believes that his friends are watching less television. The father believes that his son is watching more television, way too much television. This is important. The alternate hypothesis is less than 2. Because look what the father's trying to show. The father is trying to show that the sample that he took of the kid's friends from the high school, random sample, he's trying to show that the friends watch less television. That's what he's trying to prove. That's what the alternate hypothesis would be. The son's claim, innocent until proven guilty, the father's trying to show that his friends watch significantly less. Yes, I understand that 2.01 is greater. I understand that. But if you're talking context of the problem, You're going to have to go less than in this case. Let's talk about some assumptions and conditions. Assumptions and conditions, random sample stated. Now, he took a random sample of watching times from boys at the Suns High School, so I could say that 10 is less than 10% of boy population, boy pop in high school. To be more specific, it's the high school that the student attends, or the kid attends, or something along those lines. So it's not all high schools, I would say, something along those lines. You could say that TV watching habits are assumed independent. Clearly, if it's a random sample, then I mean, one boy's TV watching habits aren't going to affect another boy's if it's a random sample. If you're only picking two best friends or something like that, clearly two best friends are going to might be watching the same amount of TV on average or something along those lines. But random sample, 10% of the population, independence. I'm also going to have to talk about nearly normal. And in order to do nearly normal, you're going to need to look at a quick histogram. So if I'm looking at this quick histogram right here, list 1, zoom 9, heck yeah. Oh, let me get rid of that graph. There we go. That's clearly nearly normal. And I'm going to sketch that. Just going to sketch that a little bit. Add some happy trees here. There we go. Boom. Histogram. It's clearly nearly normal right there. Yeah. If you wanted to give that a little title, this is boys. This is like sample boys hours watched, something like that. But it's clearly nearly normal. Yay! Boom. I'm allowed to run what I want to run, which is a one sample t-test. Perfectly acceptable. So, what am I going to type into the one sample t-test? If I go to tests, and I go down to t-test, go over stats, a lot of that information is already there for you. The X bar is there, the S is there, the N is there. The mu is 2. And again, yes, I understand that 2.01 is indeed greater than, but the context of the problem calls for you to go less than. The context of the problem. This is one of those, not trolling problems, but trickier problems, I should say. So mu sub 0 is 2, x bar is 2.01, s is 0.335, n is equal to 10. We're doing mu is less than mu sub 0. Calculate. If you calculate that, you should be getting a p-value of 0.536. Now that p-value is way too large. Way too large to reject anything. Zoom out just a little bit here. There we go. And go back in. There we go. Perfect. Because of that p-value, I am definitely going to fail to reject that null hypothesis. It is not low enough. If the p is low, the hoe must go. That p-value is way too high. So, conclusion. I fail to reject the null because p-value is too high. There is, now you could say there's not enough evidence. There's like no evidence. With a p-value that high, it's just basically like, it's like, you can't even say there's not enough evidence. It's just like, there's like no evidence, but I'm just going to say there's not enough evidence, just to stick with the words that we typically use. There's not enough evidence to suggest the man's son watches too much TV. In fact, you can go a little bit farther with this. In fact, one could argue his friends watch, you could say the same or more. I would say the same amount on average. There we go. That would be perfectly acceptable for this particular problem. It just would be. Now, I want to try out a link. I don't know. Wait, let me go back here. People saying, oh, McKenna. McKenna, you are here. So this is the link that I sent you earlier. I'm just going to paste it into the chat. And I'm going to see. Boom. I was doing it from my phone earlier, so I have no idea whether or not this particular website will work, but let's just see if it does. If you go to the link that I just put into the chat, I'm going to put in a population mean of 2. Now it says sample X. I'm going to type in 1.9, 2.3, 2.2, 1.9, 1.6, 2.6, 1.4, 2, 2, 2.2. Let's see what it does here. We're going to do a significance level of 0.05. We're going to do one-tailed. Calculate. Let's see if it did anything. Oh, interesting. Nice. Okay, so this website, it doesn't give you the option to do less than or greater than. It does not give you the option to do less than or greater than. I'm going to assume with everything that they have on there, and I'll probably have to find a better website than this, but I'm going to assume that the automatic setting for one tail, the automatic setting is greater than. And for the p-value, the value of p, 0.464451, since that one would be greater than and we wanted to do less than, you would do 1 minus that p-value. But regardless, the result is not significant at the 0.05 level, meaning fail to reject. Not enough evidence. I will have to see if I can find a better interactive website than that. I might have one. Let me just see if this one works here. Okay. Ladies and gentlemen, look in the chat in a moment right now. Check out that website. Go to that website. This is a mathematician by the name of Matt Bogner. If you go to his website, you click that link, it'll take you to statistical inference for mu. His typical website looks like this. I'm going to put another link in there. Chapow. There we go. That's what his typical website looks like. But if you go to the one I sent you, the original one, statistical inference from mu, you could type in a sample size of 10. You could put in an X bar of 2.01 and S is equal to... Wait, why is it not doing anything? S is equal to 0.335. Does his... and if you hit enter, there we go. Then everything pops up. If you type into that Matt Bogner website, if you, the one I sent you, one of those links, statistical inference from mu, you type in n equals 10. Wow. Okay, I'm not even going to comment on Jacob's statement, but anyway. You type in n equals 10, x bar equals 2.01, S is equal to 0.335 because you don't have sigma, you have the sample standard deviation. If you hit enter, a thing will pop up which gives you an opportunity for a significance level. And I can type in 2 and 2 for both of those, and I can do less than the one that I wanted to. It not only calculates the confidence interval for you, but it also gives you the p-value as well. McKenna, if you go to that link, that is the greatest possible thing you could find for a t-test. It's not going to say t-test, statistical inference from mu. You're going to have to actually set it to be S instead of sigma, and that will make it do a t-test rather than a z-test. So But yeah, ooh, there's an updated beta version. Oh, where you can enter in raw data. Oh my gosh, I am totally suggesting this website. Yeah, um, go to the Matt Bogner website, ladies and gentlemen. I'm going to delete the other one. Remove that. There we go, it's gone. Message retracted. But yeah, the one that I put for where it says homepage dot divm whatever dot ui dot edu. That's a fantastic stat website. I'm probably going to recommend that from here on out for doing t-tests. It's phenomenal. P-value, test statistic, critical value. It's so phenomenal. I love it. 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 Cool. Okay, back to this. I wish I could show that website at the same time that I'm doing this, but unfortunately my computer has significant lag. Maybe I'll have to do like a tutorial video that I just don't do live or some junk like that. Let's talk about graduation tests. Many states mandate tests that have to be passed in order for the students to graduate with a high school diploma. A local school superintendent believes that after-school tutoring will improve the scores of students in the district on the state's graduation test. A tutor agrees to work with 15 students for a month before the superintendent will approach the school board about implementing an after-school tutoring program. The after-school tutoring program will be implemented if student scores increase by more than 20 points. The superintendent will be using alpha equal 0.02. So this is one of those situations where you can't use 0.05, you have to use 0.02. Write appropriate hypotheses in words and in symbols, it's asking for. Okay, well, they did say words, so I'm going to do the symbols first. But if you're doing something like this, the after-school tutoring program will be implemented if student scores increase by more than 20 points. Now, I'm going to do this a little weird. Keep that in mind. But mu the difference is equal to 20. Mu the difference is greater than 20. Let's just do it like that. It's a little strange. This one is a little strange because of the wording of the question. You have to remember that a null hypothesis means that there's nothing strange going on. A null hypothesis is there's no change, innocent until proven guilty, nothing's going on. If you were to think of it in that sense, the null hypothesis would be that the program did not do what the principal was hoping for. No, I'm sorry, superintendent was hoping for. The words are, the after-school tutoring program will be implemented if student scores increase by more than 20 points. Let me focus. There we go, a little better. If you were to reject the 20 points, that would mean that the program is actually working. If you were to fail to reject the 20 points, meaning, it didn't do what it was supposed to do, it's not any better than the original program, or there is no real difference between the two. That would be failing to reject. So in words, the difference, that's why I did the little subscriptive D, the difference from before and after is not more than 20 points. And the alternate, the difference from before and after is more than 20 points. That would be a proper way of going about that. In this context, what do you consider a more serious, to be more serious, a type 1 or a type 2 error? Now, typically speaking, a type 2 error is usually worse. Think the parachute example. If you fail to reject the parachute and then you jump out, you're dead. That's a type 2 error. But first, let's just kind of walk it through a little bit. I'm gonna write out both. A type 1 would be rejecting. A type 2 error would be where you failed to reject. For that type 1 error and rejecting, that means that you are rejecting the 20 points. Or I'm sorry, not more than 20 points. If you reject, that means that you are saying the program works. The program works. If you are failing to reject, the program doesn't work. If the program works, you implement the program. If the program doesn't work, you say, goodbye, program. Which one is the more worse error? You have to look at it within the context of the problem. If you believe that the program works, that means that you're going to be spending money on getting people to do after-school tutoring. They're going to give up their time. The teachers are going to, whoever's doing it's going to get paid. The students are going to go through all of this work. But if you made a mistake, that means that, well, in reality, you're going to be spending all of this money on a program. So hold on. Spent money on a program that doesn't work. Whereas if you believe the program doesn't work, when it actually does, you're going to be missing out on a chance to improve student scores. Which one's worse? Now, I'm asking you now in the chat, for those of you that are here, for those of you that are liking and sharing and subscribing, kind of outline these two. A type 1 error, you're rejecting the 20 points. You're saying the program works, when in reality it doesn't. So you spend money on a program that doesn't really work, and you're wasting money. Whereas type 2 error, fail to reject, meaning, we don't believe the program works, when it actually does work. You're missing out on a chance to improve student scores. You tell me, which one's worse? Why was what up for a review? Oh, Lucas's comment? I have no idea. But you think about it, you silly people. You think about it, and you tell me what you think. You say type 2 be worse. I don't know. Jacob, why? Why do you say type 2 is worse? Paige says, when I did it, I put type 2, but now I'm second guessing myself because I feel like type 1 is worse. Okay. Why? Jacob, you're saying type 2 might be worse. Why? Paige, you gave your comment. Why? Katie, you said I put type 1 was worse. Why? I'm not taking a stand here. I will in a moment, but I'm not taking a stand here. I want to know your rationale. Why do you think each particular error would be worse? You're missing out on an opportunity to achieve your goal. Okay, let's hear what other people have to say. He says, I put type 1 because if you do that, you're taking away the opportunity to give the students extra help. No, type 1 errors, you're actually using the program. And you're giving them the extra help even though it doesn't actually help them. Paige says, I think type 1 because you're wasting money and time. Jacob says, succeeding and then not seeing it is worse than being able to move on to the next option. Ooh, interesting. Okay, because... Oh, Katie said a bad word. Oh. Oh, message retracted. I don't know, guys. Should I take away Katie's moderator capabilities? It's- because improving by 15 points is still improvement. Katie, you're right. Improving by 15 points is still improvement, but we don't know that. I mean, it might be. It might be 15 points. It might be 19 points. Katie Solicitor. No, Katie just said a curse word. In my bubble of a world, I don't believe that high school students even curse. Because the ones that do in my classroom eventually stop because they realize, oh, Mr. Markey doesn't like it. Okay, here's the answer. You ready? I'm going to read to you the answer word for word. Listen very carefully. Listen very, very carefully. Because you're gonna love and hate this. A type 1 error would be very expensive for the school district. A type 1 error would mean that the superintendent thought the tutoring program was working better than it was, so he would implement the program. In reality, the after school tutoring program did not improve student test scores, so the district would be spending money on a program that did not help. There is a note, and I'm going to put it into the chat in a moment. Note. Students could argue that a type 2 error would be worse. Oh, I ran out of room here. Hold on. Yeah, I'll do cut. Oh, man. Sorry, I'm trying to paste this statement into the chat, but it's not letting me because apparently it's too large. Come on. Let's try this. Cut. Paste. Cut. And paste. Perfect. There we go. Nailed it. That's word for word what the answer book actually says to that problem. A type 1 error would be very expensive to the school district, blah, 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 blah. But then you can look at the note at the bottom. Note, students could argue that a type 2 error would be worse. What it comes down to? Your opinion. But you have to back up your opinion with proper statistical wordage. You have to. There are some instances in which it's cut and dry. Skydiving. You're dead. You can't argue that being dead is not worse than not skydiving. But in this particular instance, you could technically argue either one. And you guys did. Thank you for that. You did argue in the chat, one way or the other. So, good for you. Let's talk about the last part. After this trial produced inconclusive results, the superintendent decided to test the after-school tutoring program again with another group of students. Describe 2 changes he could make in the trial to increase the power of the test. Hold on, I'd rather put bread into something and realize why I wasted my bread than not realize I wasted bread at all. Well, again, that's your opinion. Yeah. But anyway, describe 2 changes he could make to increase the power of the test and explain the disadvantages of each. There are a number of ways that you could have done this, but the 2 main ways that you could do this is you could increase the significance level. You could increase the alpha level. The alpha level right now is at 0.02. If you increase alpha, you decrease beta, thus increase the power of the test. That's one simple way. But disadvantage, it could lead to adopting the tutoring program that actually doesn't help. It might. It could. Because if you raise alpha, you raise the chances of making a type 1 error. You could also increase the sample size. By increasing the sample size, basically you're spending more money for something that might even, again, be inconclusive. So you might be wasting more money. Although again, Jacob wants to put bread into things. I don't know. Here, give me a second. Hold on. I'm trying to read something. I'm live again. I reconnected. Just to be sure, did I really reconnect? Somebody tell me in the chat whether or not I reconnected. Nobody's telling me in the chat. Ah, there she is. Yes. Okay, good, and more good. Sorry, I'm checking my email while I'm talking to y'all. Okay, here's what I'm gonna say. Oh, by the way, I just talked about Part C again. Let me just zoom back in on that. Oh, no. There we go. Just again, the two things that you could do, you could increase the alpha level to increase the power of the test, but by doing so, you increase your chances of making a type 1 error, meaning you increase the chances of spending money on a program that doesn't actually work. Number two, you could increase the sample size, which, more money. You spend more money on a larger sample size, because the more students that you have, the more teachers you might need. Because if you have like 30 students instead of 15, you might need 2 teachers to do that. So, well, Lexi, just to be sure about the type 1, type 2, that all depended on the hypothesis, which the hypotheses here were a little bit weird because you were talking about the difference between the two. These problems are designed to be a little bit tricky. Here's what I'm going to suggest. I got to go check with my wife real quick about something. When I come back, which should be in a few minutes, I am going to be working off of the 2001 AP test. So, in the description to this video, there are links. And the one that you should be aiming for is the one that says 2001 AP test questions. It is a PDF file. Open that up. Take a look at a few of the questions. I would like to go over them in a couple minutes when I come back. So down in the description, 2001 AP test. That's what I want to review for the remainder of this live stream. I will be right back. Okay. Sending my wife a message. I'm back. I'm back. So, for those of you that are interested, the 2001 AP test is the very test that I took when I was in 11th grade. It was a great test. It's a wonderful test. I don't remember it at all. I don't remember it at all. It was one of those things. Let me see if I can actually print out. I'm not going to do every question. I would like to do numbers 1 through 5, 6, 9. I just want to print out the proper pages so that there we go. There we go, 4 sheets of paper. Print that sucker. There we go. 2001 was a strange year. I'm waiting for them to print. Anyway, while they're printing, I would like to talk about the first question that we got there. Move this out of the way. Ah, there's the first page. Let me also, I gotta zoom out just a little bit. Great. Oh, that's the fifth problem. Silly. I will start with number one. There we go. Nailed it. Okay. Now, this AP test that you guys will be taking, this really weird online 45-minute test, whenever they decide to get the information out about that, will be free response questions. Unfortunately, they're not going to have multiple choice. This is a really strange year, and I don't like it. But them's the breaks that we've been dealt. So, I'm looking at this question. The summary statistics for the number of inches of rainfall in Los Angeles for 117 years beginning in 1877 are shown below. And they give you all this information. Now, one thing I want to point out. TR mean is not something you're going to have to worry about. It's not something you're going to have to worry about. TR mean. True mean is what they're actually saying. It's a weird calculation. The formula is not something typically used in basic statistical classes, so you're not going to have to worry about that. Put it out of your mind. We're going to focus on the rest of that data. So, describe a procedure that uses these summary statistics to determine whether there are outliers. Now, I ask you, those watching me right now, I know that there are two procedures. There are two basic procedures that you know how to determine whether or not there are any outliers to this particular set of data. And I'm going to leave it to you in the chat. What do you got? What do you think? Obviously, typing certain formulas into the chat would be not impossible, but a little bit weird. But I want to see what you think first. I asked and immediately somebody dropped out. They'll be back. Oh, they'll be back. There are two specific things that you can do. What does one think? Whoop. I see a couple responses. Z-scores. No, it's just one response. Yeah. You totally could do Z-scores. What would be a quote-unquote outlier for Z-scores? What would be a quote-unquote outlier for Z-scores? Yeah, in either direction. Absolutely. And again, you would write that out. You would write that out in words. You could say something to the effect of, I don't know, what's the wordage? An outlier would be a data point that is more than 2 standard deviations above or below the mean. Done. Fantastic. What is the other way? The other way we could determine whether or not there are any outliers. And again, I would put this out into words, of course. I'm not going to write this out right now, but I'm just going to, you could do Z-scores, or, yes. And I will write this one out, Q1 minus 1.5 IQR, comma, Q3 plus 1.5 IQR. You could do that as well, and just explain that any data point outside of that range would be considered to be an outlier. Now, the beautiful thing is, for part A, they just say to describe the procedure, describe a procedure, meaning you only have to describe one procedure, which is just fantastic. You don't have to do both. Just do one. If you were to actually do these calculations, which they are asking for you to do, are there any outliers in the data? Are there any outliers in the data? Checking my notes right here. There it is. I calculated the IQR range to be negative 4.675 to 33.605. I'll do the standard deviations in a moment. But if you notice this is the 1.5 IQR calculation. Look at the min and look at the max. Are there any outliers in these data? Justify your answer based on the procedure that you described in Part A. How would you answer that? They say justify your answer. They say, are there any outliers? Now, wonderfully, they don't ask you how many outliers, because I want to be very clear about something. They said, are there any outliers? And of course, you would say yes. You would definitely say yes, because the maximum is outside of that range. But if the problem were asking you how many, the only thing that you could say is at least one. You would say at least one. You couldn't say that there is just one. You don't know that for sure. There could be multiple data points above 33.605. So you would say at least one, but yes, there is. If you were to do the standard deviation calculation with the z-score, the z-score one, I have it written here, 1.447 to 28.435. Again, the answer is the same. Yes, there's at least one outlier. Part C. The news media reported that in a particular year there were only 10 inches of rainfall. Use the information provided to comment on the reported statement. I'm just going to walk you guys through this one because I want to make sure I get to some of the other problems here. And this one's more a little more straightforward than normal. Only 10 inches of data? There's two ways of dealing with 10 inches of data. Number one, 10 inches of data is greater than Q sub 1. 10 inches of data is greater than Q sub 1. Meaning that 10 inches of data is greater than 25%, at least greater than 25% of all data points. That's not unusual. It's in like the 25th percentile or more. That is not unusual. You could also do the z-score calculation if you wanted to. You could do, where is it? 10 inches minus 14.941 divided by the standard deviation. Let's see what that calculates out to become. 10 minus 14.941 divided by 6.747. Boom. That is approximately negative 0.732. That is within one standard deviation of the data. That is clearly not unusual. So if you had to comment on there being only 10 inches of rainfall, that's what they're kind of aiming for. What they're trying to say is that the news media is trying to report that 10 inches is an unusual number. All right. Let's look at number 2. I find it of utmost importance that we talk about number 2 on this test. Can anyone tell me why? Why is number 2 of utmost importance that we review this problem? Does anyone remember? I don't think y'all remember. I'll tell you. I gave you this problem on an assessment, and we had a bit of issues with it. But I gave you this problem on an assessment. It's a wonderful problem. I love this problem. I love this problem with a passion. A department supervisor is considering purchasing one of 2 comparable photocopy machines, A or B. Machine A costs $10,000. Machine B costs $10,500. This department replaces photocopy machines every 3 years. might as well just underline that for now. The repair contract for machine A costs $50 per month and covers an unlimited number of repairs. I'll deal with that in a moment. The repair contract for machine B costs $200 per repair. Okay. Based on past performance, the distribution of the number of repairs needed over any 1-year period for machine B is shown below. You are asked to give a recommendation based on overall cost as to which machine, A or B, along with its repair contract, should be purchased. What would your recommendation be? Give a statistical justification to support your recommendation. What do you need to know in order to do this problem? And Katie, this actually goes back to what we talked about the other day. What you helped your friend with. Something specific that you helped your friend with. Or maybe it wasn't your friend, I don't know. Maybe it was just some random person that you decided to yell statistical knowledge at. Yeah, it is. I hope you all remember this problem. This problem is about expected value, as she just said. So, we got to break this up to machine A, machine B. Machine A. Now, machine A cost you $10,000 plus $50 per month. Why would you yell at somebody if they were only 6 feet away from you? Anyway, but $50 per month. Now, here's the deal with $50 per month. It's over a 3-year period. They are going to replace the copy machine every 3 years, no matter what. Because you suggested I yelled statistical knowledge. Okay, fine. Fine. This problem is over a 3-year period. If it's $50 per month, that's $50 times 36 months. As a result, if you were to do this calculation, over the course of 3 years, machine A would cost you $11,800. Now, machine B. Machine B cost you $10,500 plus $200 per repair. But at this moment, you don't know how many repairs there will be. You don't. You might have 0 repairs. You might have 3 repairs per year. That chart that they gave you is over the course of 1 year. So, if I were going to do expected value, it would be something along the lines of this. If I did that calculation, I would get 0.85, meaning that in any 1 year, I am expecting, on average, to have 0.85 repairs. Now, that's not, I mean, how could you have less than 1 repair? Again, this is expected value. If you had 1,000 companies doing this, and you average together the number of repairs that they would have over the course of 1 year, it would average out to be 0.85. Some would need 0, some would need more than 1. But now, over the course of 3 years, in 3 years, multiply that by 3, there would be 2.55 expected repairs over the course of 3 years. Since $200 per repair, you do that calculation, altogether it would come to $11,010. This is what you need to get this problem done correctly. You need the show of expected value, you need the understanding of the 3-year calculation, and the ultimate final cost of machine A and machine B, and the recommendation. Recommend machine B because of lower cost over 3-year period. Done. That was an expected value problem that I gave you for an assessment. I don't remember which assessment it was, but that's the one I gave you. Oh, phenomenal. Do I want to jump to that one right now? I want to jump to number 4. I'm going to skip number 3 for now. But I want to jump to number 4 because I want to do 4 and 5. And this is what I want to wrap up today with, is numbers 4 and 5. I'm skipping number 3 mainly because that's like a problem from very, very early on in the year. And I had talked briefly the other day about doing a problem similar to that on one of the reviews that we did. But of course, I can review that another time if you need to. But let's talk about number 4 here. This is an amazing problem. Well, I should say number 5 is better, but students are designing an experiment to compare the productivity of 2 varieties of dwarf fruit trees. The site for the experiment is a field that is bordered by a densely forested area on the left side. The field has been divided into 8 plots approximately the same size. The students have decided that the test plots should be blocked. 4 trees, 2 of each of the 2 varieties, will be assigned at random to the 4 plots within each block, with 1 tree planted in each plot. The 2 blocking schemes shown below are under consideration. For each scheme, 1 block is indicated by the white region, and the other block is indicated by the gray region in the figures. They're asking which of the blocking schemes is better for the experiment. This is probably one of the most misinterpreted problems I have ever seen. Bar none. If I gave you this problem on an assessment, I would argue that 75% or more of you would pick the wrong scheme. Guaranteed. Guaranteed. Which one do you pick? Which one do you pick? I'm giving you an opportunity to kind of think about it as I kind of try to dig into your brains a little bit. There is a definitive answer, just so you know. You don't have to answer in the chat. I just really want you to think which scheme is best. And again, if you want to reread the wording of the question, let me bring this down just a little bit. They're trying to compare the productivity of 2 varieties of dwarf fruit trees. But they're going to block. What do they block by? I'm going to tell you, bar none, the answer that is preferable is A. It has to be A. The question then becomes why. The mistake that people have is they believe they have to pick B because they're seeing, oh, well, there's 2 fruit trees. One of the fruit trees is in this block, and then the other fruit trees are in this block, and, you know, they're closer to the forest, farther away from the forest. Everything will be fine. That's not what they're saying. There are 2 types of fruit trees. Varieties of dwarf fruit trees, I should say. Let's call them variety 1 and variety 2. Let's call them variety 1 and variety 2. They're saying that they are going to block the experiment. What they're blocking by is proximity to the forest. So what they're doing is there are 8 trees, and they're going to do 2 of variety 1 and 2 of variety 2. 2 of variety 1, 2 of variety 2. They're going to randomly split them, but they're going to put 2 into each block. Because look at it right here. You can't see that part. Zoom back down. There we go. The students have decided the test plot should be blocked. 4 trees, 2 of each variety, will be assigned at random to the 4 plots within each block. Meaning, if I go back up here, these 4 trees, 2 of each variety, are going to go to block 1, and they will go to block 2, in which they will be randomly assigned within the block. The answer has to be blocking scheme A. That's the preferable one. Because then you might have something like this. And again, this is just an example. You might have like variety 1, variety 2, variety 2, variety 1. And then you have an equal number of variety 1, variety 2 close to the forest, maybe not getting as much sunlight. And then maybe variety 2, variety 1, variety 2, variety 1, because they're going to be randomly assigned as well, and they're all going to be having the same amount of sunlight away from the forest. This is the proper way of doing the problem. Which of the blocking schemes is better for the experiment? That's the question. One way you could word this problem, is blocking scheme A is preferable because of the exposure to the forest. Plots that are in the same block, or varieties that are in the same block, will have similar exposure to the forest. Whereas, if you chose blocking scheme B, there is a chance, small chance, but there's a chance that you might get all variety 2 close to the forest, and they would not have the same circumstances of variety 1, and the results of your experiment would be disastrous. You got to choose blocking scheme A. Even though the students have decided to block, they must randomly assign the varieties of trees to the plots within each block. What is the purpose of this randomization? I had wrote when I was doing this problem, the randomization reduces bias, the bias in the fertility of the soil, moisture, things of that nature. Yeah, I mean, the soil could potentially be biased. I mean, even though, yeah, they're all close to the forest in this particular block, one might have like a natural divot of water somewhere, a natural irrigation or some chunk like that, or this one, even though being farther away from the forest and getting more sunlight, one might be closer to the road or some chunk like that, some environmental factors. But by randomizing, you reduce that bias. It equalizes the effects in relation to where the trees are, basically. There always must be some form of randomization in terms of experiments. I don't want to go over number 6. I did not print that one out because number 6 is a problem that you will not be faced with on this AP test. I guarantee it. Also, I have to wrap this up soon because I, within the next half an hour, have to be driving up to Freehold to potentially have my daughter's arm in a cast. Yay! Okay, sorry to be glum right there. Number 5. This problem is fantastic. This problem is a T-test problem. To be more specific, it is a matched pair T-test. This is something that I have not taught you, but you have enough information to get through it. I guarantee you that you do. Guarantee you. This is a phenomenal problem. And I highly recommend rewatching us review this problem when the time is appropriate. But let's talk about it now. A growing number of employees are trying to hold down the cost that they pay for medical insurance for their employees. As part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescriptions. An independent consumer advocacy group wanted to determine if there was a difference in milligrams in the amount of active ingredient between a certain name brand drug and its generic counterpart. Pharmacies may store drugs under different conditions. Well, that's important. Therefore, the consumer group randomly selected 10 different pharmacies in a large city and filled 2 prescriptions at each of the pharmacies. So, like, here's one of a CVS across the street from Wawa, and here's one, the Rite Aid at the corner of Bay Avenue and Barnegat Boulevard, and here's the Walgreens, and here's the place inside Acme or some junk like that, and here's some back alley place behind, your friend's house. I don't know. Don't care. But I lost my train of thought. The consumer group's laboratory then tested a randomly selected pill from each prescription to determine the amount of active ingredient in the pill. The results are given in the following table. Okay. Let's see what we can do here. They give you 10 different pharmacies. Yes, they got a name brand and a generic from both, but your end value is 10. Please keep that in mind. Please, please, please keep that in mind. Based on these results, what should the consumer group's laboratory report about the differences in the active ingredient in the 2 brands of pills? Give appropriate statistical evidence to support your response. This is a paired t-test. This is a matched pairs t-test. Here's what your null hypothesis is. Let's talk about a null hypothesis. First of all, they're talking about the difference between the 2. One way of stating this null hypothesis. The null hypothesis is that the mean of the difference is equal to 0. We're going to have to do the mean of the difference. The alternate is that the mean of the difference, because of the context of the problem, we're going to have to do not equal to 0. Alternate, alternate, alternate. There we go. The reason why this has to happen is because there is a link between the name brand and the generic, meaning the pharmacy that it came from, and the statement that kind of fills that out for you. The statement that kind of shows you that you need to do a matched paired t-test or a paired t-test is pharmacies may store drugs under different conditions. Meaning CVS may hold their drugs in different physical conditions than Walmart or Rite Aid or Walgreens or that guy's alley. Who knows? But because of that, the name brand and the generic would be under similar conditions within that store or within that store or within that store. We're going to have to look at the difference between the 2. One little note you could make for yourself. You could say that the mean of the difference would be the name brand minus the generic. You could do something like that. That would be perfectly acceptable. But yeah, that's what we're looking at. The mean of the differences. You could also go, another way of putting this would be the mean of the name brand minus the mean of the generic is equal to 0, and the alternate could be something like this. That's also acceptable as well. Let me show you what the calculator should do. Make sure I got these numbers correct. In my graphing calculator, I'm going to need to type in the following. Now, you could do this in one of 2 ways. You could literally subtract them and then type them in, be like, okay, subtract them in that order. -1, 4, 5. You could type it in like that. You could also type them in like this. There we go. And boom. You could type them in like that as well. I just gonna double check real quick to make sure that my numbers are correct. I need to make sure that they now, but you are looking at the differences between the 2. And you are pairing them together like this because of that statement. Pharmacies may store drugs under different conditions. I am interested in the difference between the drugs from one pharmacy to the next. If I highlight L3, I could do L1 minus L2 and get the differences right there. Then you're going to want to do a 1 var stat, but you're going to want to do it using L3. Using L3. Boom. That's the data that we need. That is the data that we need. Let me write down some of this information so that we have it. First of all, as I said, the n is equal to 10. I got an x bar of my difference is equal to 6.6. My standard deviation of the difference is equal to 5.27. Of course, that information, because I ran the 1 var stat, would automatically be entered into one of my tests. We're all good there. But I want to use a t-test. And it's a matched pair t-test, so I'm just going to do a regular t-test right in the calculator. But in order to do that, I'm going to need to check my assumptions and my conditions. So, first of all, random sample stated. Now, independence could be stated in a couple different ways. Independence could be stated in a couple different ways. You could say independence of storage conditions between pharmacies. That's one way you could state independence. Another way you could state independence is independence of, I want to say active ingredients. Yeah, of active ingredient within brand. Something along those lines. Independence is hopefully assumed based on the random sample that was being stated. You could say that 10 is less than 10% of all pharmacies. Something along those lines. Not brand pharmacies or some junk like that, because I don't know if there are like 100 or something like that pharmacies in the country. But I mean, this might be like the CVS in Barnegat, and this might be the CVS in Waretown or some junk like that. And that would be perfectly acceptable. So like 10% of all pharmacies, so to speak. But we also have to talk about nearly normal. You have your data saved in your calculator. You could do a histogram, but you'd have to do L3 because that's where we had the data for the differences. If I zoom 9 that sucker, this is where we get the fluffiness of statistics. That's close enough. Unfortunately, that's what we have to do. That's close enough. Or nearly normal enough, or some junk like that. If I was drawing this thing, can you see that? You can't see that. Move that up a little bit. There we go. If I was going to draw this thing, yes, I agree. It looks skewed to the right. Absolutely, yes, it is. But you could even state that, like, nearly normal enough, looks skewed right, but we will proceed. Something along those lines. The wonderful thing about statistics is that you can kind of, like, muck it at that point and just be like, hey, it's close enough. Whatever. But now we can do the t-test. So I'm going to do a t-test. And all of my information is there, except for the mu sub 0, which I got to do 0 there. On average, they had a difference of 6.6, meaning the generic brand, on average, had 6.6 less milligrams than the name brand, because we subtracted it in that order, name brand minus generic. Standard deviation is already there. Sample size is already there. We're going to do not equal to based on the context of the problem. All they wanted to know, whether or not there was a difference between the two. I'm going to calculate that sucker. Actually, let me write that stuff down first. Mu sum 0 is 0. This is under t-test. X bar is 6.6, S is equal to 5.27, N is equal to 10, mu is not equal to mu sub 0, and I get a p-value of 0.0033. Hold on a second, somebody's knocking at my door. Can you give me a few minutes? I'm just wrapping up. That was my son asking for a piece of candy. Anyway, I get a p-value of 0.0033. What does that mean for us? Since 0.0033 is less than 0.05, we reject the null. There is evidence to suggest the mean difference of active ingredient between name and generic brand. If I can spell brand. There is evidence to suggest. I'll give him candy in a little bit. You calm down. There's evidence to suggest the mean difference of active ingredient between name and generic brands are not the same, or not the same, are the difference. Oh, I'm sorry. I am losing my mind. It's been a long day. I already talked about the mean difference. The mean difference between them is not 0. That would be a better way of putting it. You could also, now, yes, you could argue that the name brand on average has more, but that's not what they were asking. That's not what they were asking. They were interested if there was a difference. You could also say there's evidence to suggest that there is a difference between the amount of active ingredient between the name and generic brand. Something along those lines would also be appropriate. Again, you could say, oh, the name brand is more, but again, not what they were asking. If you wanted to run a separate test, by all means, run that separate test. Anywho's it's. It is 2:30. I am going to have to leave in like 15 minutes to drive to Freehold to go get my daughter's arm casted, which is oh so fun. You know, I have never broken a bone. I am 36 years old and I have never broken a bone. My wife has never broken a bone. My daughter's not even 2, and she broke a bone. What a great day. I didn't post a picture on Twitter earlier today, mainly because I was running around like crazy trying to get things done for my daughter to get ready for the appointment. I had to stop and go get the x-rays and all this other stuff. But I'm probably going to post a picture of her in a cast if she gets a cast for sympathy likes. I don't know. Anywho, I'm going to put timestamps on this hopefully before the end of today, this video, so people don't have to wait to get to certain problems. I'm also going, as I promised, going to assign some kind of assessment early next week in regards to t-testing. Who is that? And why is their name inappropriate? Katie, block them. That was... I'm sorry. It has been a very long day. Can somebody please tell me who the heck is Anna? said I'm Anna. Anna. Wow. Thank you for blocking them, Katie. No, they first of all, their name was inappropriate. Second of all, the last message, I don't know if Katie, if you can see the deleted message that you blocked. Um Whoever this person said was they said their name was Anna. And then can you see the name that they gave the full name? Yeah, exactly. That's just ridiculous. People are dumb. Oh goodness. But yeah, I'm gonna sign off. This is why I have moderators to do that kind of stuff for me. But anyway, I will be in touch with you guys. I'll probably send you something over the weekend. Yeah, I'm out. Email me questions.